So here's a problem that we're solving. We want to get it into triangular form, meaning I want to get rid of this term entirely. So let's highlight the terms that we want to get rid of. I want to get rid of this term entirely, and this is the order that I will go in. That's first, then the one right above it, I want to get rid of them, then the one right next to it. The difference between solving this way, using Gaussian elimination, as opposed to substitution or elimination, which we've done previously, is before we would eliminate entire equations, and whereas we started with 3 equations, after a while we would only have 2 equations to work with. That's not what we're doing here. We have 3 equations, and we're going to stay with 3 equations until, the end of the problem. It'll never, none of them will ever be eliminated, but the terms will be. So first, you scan your equations, and if there is an equation that you can divide entirely by a number and get whole numbers, go ahead and do that first, because it just gives you smaller numbers to work with. So that's what we did first. We divided everything in equation 1 by 5, and I wrote that here. Everything that you do, you keep a record of it so that afterwards you can backtrack your steps. So we divided equation 1 by 5, and we got cute little numbers like this. Next, I want to move on to eliminating my terms. This is the one I want to eliminate. And, a few tips or tricks of the trade here are this. Circle the one you want to get rid of, okay? When you circle the one that you want to get rid of, what happens is that row now is going to get replaced, okay? So think about it. All right, I want to get rid of a 3x. Look at his friends in that column. You've got a negative x and an x. And just focus on this 3x. What can you combine this 3x with here in order to get rid of it? Well, one thing is I can multiply this by 3 and just add it to this, right? So this is equation 2. I can multiply equation 2 by 3 and add it to this. And that's what I did here. 3 times equation 2 plus equation 3. And I got a 0 here. 3, and you do the same thing to every single term. 3 times 2 is 6, minus 2 is 4, 4y. 3 times negative 3 is negative 9, plus 7 is negative 2z. 3 times negative 12, negative 36, plus 30 is negative 6. All right? Next, what I want to do is get rid of this term, the negative x. All right? And again, look at the members of that column. What can I combine the negative x with in order to get rid of it? In order to make it 0. Right, if I just add it to this one, positive x, then it goes away, right? So what I'm going to do is equation 2 plus equation 1. All right, now, I'm changing row 2, or equation 2. That means equation 1 and 3 remain unchanged, and I simply copy it over here. So I have x minus y minus z equals 7, and equation 3 is, I don't write the 0 anymore, 4y minus 2z is equal to negative 6. So what I'm going to do now,
Wait, shouldn't it be minus 40? If you're adding it?
okay, so right now I'm not doing anything. I'm just copying equation 1 and equation 3. Are those going to change? Those are not going to change. The only one that's going to change is the one that has the term that I've circled. All right? So now I'm going to start adding. So what I'm doing, again, make a record of it so you know afterwards, and you can trace your steps if you have to. I'm going to add equation 1 plus equation 2. So I write that off to the side here. 1 plus E2. Now, let's add E1 plus E2. X plus negative x is 0. Negative y plus 2y is 1y, so positive y. Negative z plus negative 3z is negative 4z equals 7 plus negative 12 is negative 5. Okay? Now, the next one I want to get rid of is this one, and that's going to be the last one for me to get rid of here. Okay? Yeah.
Why did you write E1 plus E2, but if you have the equation for 3 in there?
I'm not touching equation 3.
Just bringing it down.
Okay, so what I did is I want to get rid of this term, right? That's in equation 2. That means equation 1 and equation 2 remain untouched. Okay? All right, let's do this one here. So now I want to get rid of 4y. Which equation is that in? 3. That means equation 3 is the only one that's going to change. 1 and 2 stay the same. So here I have x minus y minus z equals 7. Y minus 4z equals negative 5. Now, equation 3. I want to get rid of the 4y. So look at this set of equations here. I want to get rid of this one. Look at the ones in its row, right? So the best thing I can do is multiply this one by negative 4 and add it to this. So equation 2 by negative 4 and add it to this. So I'm going to do negative 4 equation 2 plus equation 3. Now, why can't I combine this with equation 1?
Because that doesn't make sense.
If I combine it with equation 1, then I'm going to reintroduce the x here, which I just got rid of. All right? So for the last step, use these two equations at the bottom. Okay? All right, so let's do that now. Here, negative 4y plus 4y is 0. Now, negative 4 times negative 4z plus negative 2z, how much is that? Positive 16 minus 2 is 14z equals negative 4 times equation 2, so negative 4 times negative 5 plus negative 6, 14. Okay? This one, so I'm doing negative 4 times this plus this. Negative 4 times equation 2 plus equation 3. Now, look at row 1. That's fine because now I have to make sure that in each row, the first coefficient is a 1. Here you have 1x, so that's good. I just copy that over. In the second row, that's fine as well because the first coefficient is a 1. Well, what about in the third row? I have 14z equals 14. What do I have to do? Divide by 14. So I say 1 over 14 times equation 3 gives me z equals 1. Now, this is triangular form. Right? That's what we were talking about up here. Okay? It's also referred to as row echelon. And I will use row echelon more often, so if I say reduce it to row echelon form, this is what I mean. Now I need to solve for x, y, and z. To do that, I do what is called back substitution. Yeah, well, I need to solve for x and y. All right, so from equation 3, I know that z is equal to 1. Perfect. Now I move back to equation 2. Equation 2 says y minus 4z is equal to negative 5. Y minus 4 times what z? 1 equals negative 5. So how much is y? You add 4, so it's negative 1, right? And now from equation 3, I know that x minus y minus z equals 7. Equation 1. So I know that x minus negative 1 minus positive 1 equals 7. X plus 1 minus 1 equals 7. X is equal to 7. Okay? Now, what have we found? I have 3 equations. If you have an equation with just an x and a y, it's a line, right? If you graph x, an equation with just an x and a y. Well, if you have an equation with an x, a y, and a z, 3 variables, that's the equation for a plane. So imagine you have 3 planes, right? Imagine you have, for example, this wall, the ceiling, and that blue wall over there. Is there a point where all 3 of these meet? All 3 together meet at one point, the corner. What we found here are the coordinates of that one point in space where these 3 planes meet. So my answer is never in x equals y equals z equals form, but it's always in coordinate form. So I say 7, negative 1, 1. That is my answer.
Can you plug in any equations?
Yeah. You can. But, you know, like we do it this way because first you only have 1. So you need to plug it into an equation that has y and z. Yeah.
When you're doing this, to get into the epsilon form, does like the third equation you're given have to be the one with just the z?
Yeah.
It's easier to...
It has to look like a triangle.
Right, but like if it's easier to get the x and y out of the second equation, can that be the one that with just the
You have to put it in the bottom. You have to swap equations to put that one in the bottom.
It's fine if you
Yeah. Okay.
So the actual triangular form will be those 2 equations or just the same?
The triangular form is all 3 of those equations, these. This is the triangular form, this one. Okay? All right. Now, we're going to, like, this whole chapter is doing these. Okay? So, look, what we did here, we're actually going to solve that problem again in a minute. But what we did here, you know, this was fine. But you know what? Look at the x and the y and the z. Like, they don't really do anything other than being a nuisance, right? You're just copying the x, y, z over and over and over and over again. What if they weren't there? Because really all you're doing is manipulating and changing coefficients. So what if you just took x, y, what if you took the variables out of the equations entirely? Well, we can do that, and it actually makes solving this problem a lot easier, more efficient, I should say. So because the variables remain untouched, okay, you can also solve this using a matrix. Well, what is the matrix going to look like? It has the coefficients and the constant terms only. So look at this. This is the system that we just solved. 5x minus 5y minus 5z equals 35, right? Well, let's get rid of all these x's, y's, and z's. Let me just copy over the coefficients here. 5, negative 5, negative 5, and the constant term here, 35. And let me do that to all of them. The coefficient here is negative 1, negative 1, positive 2, positive 2, negative 3, negative 3, and the constant is negative 12. So do you see how I did that? I just copied over the coefficients into a matrix. Now, this is called the augmented matrix. It also has your constants, right? These are the constants. If you get rid of the constants too and you just have the coefficients, cleverly, that's just called a coefficient matrix. Okay? And whatever we did with the equations, equation 1 plus equation 2, 3 times equation 2 plus equation 3, you can do that with matrices, but, use the rows. So you can interchange two rows. You can multiply a row by another, by a number. You can add multiples of rows to other rows. And if we get the matrix into row echelon form, this is how it looks. You've got leading ones here in triangular form. Everything below is a 0. And should you have a row that is all zeros, that's always placed at the bottom. Okay? That's row echelon form. So look at these here. And let's see if any of them are in row echelon form. Is A in row echelon form?
No.
Well, let's see. My leading coefficients are 1s. And if I look at that main diagonal, everything underneath is 0. So yes. Okay? You don't have to have a row of zeros. But if you do, it has to be in the last row. Okay, so look at this one. Is this in row echelon form? No, because of the row of zeros. What about this one? Is that in row echelon form? Yes. All right. Tips and tricks. I actually told you already. So start with the one in the bottom left corner, then the one right above, and then the one right next to it. Same. Okay, so we're going to solve that same problem that we solved before, but this time we're going to do it using matrices. Yes, well, it's more efficient. I like it better. All right, so I'm going to write it in matrix form. 5, -5, -5, 35, -1, 2, -3, -12, 3, -2, 7, 30. This is my augmented matrix. So first, if there are any rows that can be divided by the same number and still give you whole numbers, go ahead and do that now. So what I'm going to do is I'm going to divide the first row by 5. I don't call them equations anymore. I call them rows. So what I'm going to do is divide the first row by 5. It's 1 over 5 R1. And that gives me 1 minus 1 minus 1, 7. Now the rest remain unchanged, so I just copy it over. Okay? All right. Same rule as before. Not rule, but like same method. It's really like it never fails. I'm going to start with this at the very bottom left corner, then the one above it, then the one next to it. Okay? All right. Circle the one you want to change. Now, copy the other rows because those are not going to change. So here I have 1 minus 1 minus 1, 7. Okay? Now, I'm going to change that one, right? So look at its friends here in its column. What can the 3 be combined with in order for it to become a 0? So I can multiply this by 3, the -1 by 3, and add it to this, right? So what am I doing? I'm doing 3 times row 2 plus row 3. And you're going to do this to every single number, okay? So, 3 times -1 plus 3. 3 times 2 plus -2. 3 times -3 plus 7, and so on. You can write it down. You don't have to write it down. It's up to you. Shall we write it down? Yeah. Okay, so we're going to do 3 times negative 1 plus 3, that gives you a 0 here. 3 times 2 minus 2, that gives you a 4. 3 times negative 3 plus a 7, negative 2. 3 times negative 12 plus a 30. There. Now the next one I need to change is which one? The negative 1, right? So this one. Okay, so look here. How do I make that a 0? I can only work with these numbers here, right? Well, what can I combine this with? Which one of these can I combine it with in order for it to be a 0? Well, if I multiply this by 3, what do I get? And if I add it to this, what do I get? 0. So I'm going to do that to everything though. 3 times this plus this, 3 times this plus this, 3 times this plus this.
So you want to just get 0.
All right, so now row 2 is going to change, so I just copy everything else. All right. Now, how do I get rid of that negative 1? Look at its buddies in that row, right? Well, if I could just add it to row 1, that'll do it, right? So I say row 1 plus row 2. And I do that to every single term. 1 plus negative 1 is 0. Negative 1 plus 2 is 1. Negative 1 plus negative 3 is negative 4. 7 minus 12 is negative 5. Now the next one I want to change is the 4 here. Okay? That means the first 2 rows will remain unchanged, so I just copy it over here. 1 minus 1 minus 1, 7, 0, 1, negative 4, negative 5. Okay, now okay, to get rid of this 4, it makes most sense to just combine it with the row right above it, right? Because these two are zeros, and if I add row 3 to row 1, I'm going to reintroduce a number here, which I don't want. It'll have undone what I've been doing. So how can I combine these two in order to get that to be a 0? Right, negative 4 times row 2 plus row 3. So 0 plus 0 is 0. Negative 4 plus 1, negative 4 plus 4 is 0. 16 minus 2 is 14. 20 minus 6 is 14. Look at that. Now what can I do? First row is fine. Second row is fine. What's the deal with the third row? I have to divide by 14. 1 over 14, row 3, 0, 0, 1, 1. Now I'm done. Okay, now I have a matrix in row echelon form. Because the first coefficient in each row is a 1. Okay? So this is in row echelon form. Now, before when we had the equations, what was the variable in the first column? The variable was an x. The variable in the y column was a y, in the second column is a y, and in the third column it's a z. Okay? So now here's how we read this. What I have here is 1x minus 1y minus 1z is 7. This is a 0, so 0x. 1y minus 4z is negative 5. 0, 0, z equals 1. Okay? So from here, I extract that from row 3, that z is equal to 1. Now, what do I extract from row 2? That y minus 4z is equal to negative 5. So let's plug in our z now. Y minus 4 times 1 is equal to negative 5. What's y? Negative 1. Well, what information does row 1 give me? 1x minus 1y minus 1z is 7. X minus, well, y is negative 1, minus 1 equals 7. So how much is x? 7. My final answer then? 7 minus 1, 1. And this is how you do it, solving using matrices. Okay? Now, yes. All right. So I did the same problem just so you see, the difference between the two. Okay, now, so this was Gaussian elimination, and in Gaussian elimination, we get it in row echelon form, meaning you have you have the main diagonal of ones, and everything underneath is zeros. Well, guess what? You don't have to stop there. So basically what we're doing here is sort of like stopping midway. You can continue this process, and you can make the ones above into zeros as well. Okay? So it's just, going like 2 more steps further. When you do that, that process is called Gauss-Jordan elimination, named for 2 mathematicians, Gauss and Jordan. And now, instead of row echelon, we get what is called reduced row echelon form. The first non-zero element is a 1, and the rest are zeros. So if you have reduced row echelon form, this is what it looks like. You've got the main diagonal of 1s. Everything else in the matrix is 0. Well, A, B, and C have to stay because those are your solutions. So now all you have to do is say, okay, X is that number A. Y is that number B. Z is that number C. Okay? This is reduced row echelon. It's the same thing. You just go like 2 more steps. So let's do one. We're going to do this using Gauss-Jordan elimination. And call it a mnemonic, call it whatever. If you have Gaussian versus Gauss-Jordan has 2 names, right? So we go a little bit further. Okay, that's how you can remember it. I'm gonna, yeah, this is done with matrices. Okay? All right, so let's write down the matrix. We have a fresh problem now. 1, negative 1, 1, 3, negative 1, 2, negative 1, 2, 2, negative 3, 3, and 8. So when you're doing your homework, it's really important to just focus, because one little addition mistake, one little, I didn't see the negative, and you get into these numbers that are totally off, and it just throws off the whole problem. Okay, so let's see if there are any rows which can be divided by a number in order to reduce, which there don't seem to be. All right, so what's the first one I'm going to get rid of? Let's keep it the way. Let's get rid of the 2. All right? So I'm going to get rid of the 2, meaning the first 2 rows are going to remain untouched, so I just copy those over. Okay, now, let's think about how we're going to combine these. Right, so 2 times this plus this gives me my answer. So 2 row 2 plus row 3. Negative 2 plus 2 is 0. 4 plus negative 3 is 1. Negative 2 plus 3 is 1. 4 plus 8 is 12. if you don't write this down, the 2R2 plus row 3, and if you're on like step number 5, and it's like the 6th problem that you're solving, it's all going to get jumbled up in your head. Wait, was I doing 3 times row 2 minus row 1? What was I doing? So write it down, okay? All right, which one am I going to change next? The negative one. Yeah, that's a 12. So that means I copy over row 1 and row 3. Okay, so what am I going to get here? I'm going to change this one. Well, how can I change that one? I can add it to row 1, right? So I'm just going to do row 1 plus row 2. 0, 1, 0, 5. Yes? Okay. What's the next one I'm going to change? The 1 here, right? So row 1 and row 2 will get copied over. Now, if you really get savvy with this stuff, you could do multiple steps at the same time. Like, you know, at each step you can do 2 things or 3 things. Okay, so I'm going to change this one. How can I get rid of that one? What can I do? Right, or I could just do, to make it simpler, row 3 minus row 1. Can we do that? Row 3 minus row 2. Okay? So row 3 minus row 2. So 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. 12 minus 5 is 7. Okay? So look, I'm almost there. I have 2 more numbers to get rid of. Now, I got lucky and I got a 0 here. Okay, that's really lucky. The only ones that now I have left to change are this negative 1 and this 1 at the very top. Okay, now you have to be clever. And here's what I mean by that. So the one I want to change next is this one. Okay? If I only want to change that one, then look, the best row to combine that with is row 2. Because all the other ones are zeros, and the only one that gets affected is that. So, because that's the, I want to do this and this, and I just picked that one first, just because. Okay? Yeah, these have to be zeros now. Well, I mean, it's not too difficult, because the main diagonal is a 1, and everything else is a 0. Okay? All right, so I'm going to add row 1 plus row 2. And what I'm going to get are 1, 0, 1, 8. Okay, these get copied over because they didn't change. The only one left to change now is this lonely little one. So again, the 2nd and the 3rd rows will not change. Same thing. It's easier to do that. So you could do negative row 1 plus row 3, or row 3 minus row 1. So I'm changing this one now, and it's going to be row 3 minus row 1. So, oh no, row 1 minus row 3. Sorry, row 1 minus row 3. Because if I do row 3 minus row 1, then I get a negative 1 here, which I don't want. I want a positive 1. So I do 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 8 minus 7 is 1. And now I'm done. This is reduced row echelon form. All right, so notice the main diagonal just has 1s, and everything else in the coefficient matrix is 0. Now, this is how, look at how cool this is. All I have to do is just match, right? Because this was my X column, Y, and Z. So all I say is this, okay, X is equal to 1. Yes? Y is equal to what? 5. And what's Z equal to? 7. And of course, though, your answer has to be in coordinate form, so it's 1, 5, 7. All right. This is amazing stuff. Like,
Easier than it was the last time.
than last week, right? Yeah.
We always playing the matrix, so we have
Minutes among friends. All right. So this first one, right? 1. All right. So let's write the matrix for this. 1, 2, 1, 8. 2, 3, minus 1, 13, 1, 1. Okay. All right, so what do we want to do here? Get a 0 where? Bottom left. So I just copy over the first 2 rows. Okay? This is a... All right, so what am I going to do? What am I going to do here? Row 3 minus row 1. That works. Could you have done row 2 minus 2 times row 3? Absolutely. You know, whatever works. So 1 minus 1 is 0. 2 minus 1 is 1. 1 minus negative 2 is 3. And what's 8 minus 5? Huh? Oh. Or we could do row 1 minus row 3. So what's 8 minus 5? This way we get positives. What else am I going to change? The 2, so let me copy over the rest. This is the best way to do it. Doesn't matter. So what are we going to do here? Right. So 4 minus 3 is 1. 2 plus 1 is 3. And that's a 3. Now, I need a 0 here. So I'll do row 2 minus row 3. But let me just copy over the first 2. And I'm going to do row 2 minus row 3. And what am I going to get? 0, 0, 0, 0. Oh my goodness. What happens here? Well, what I have here is that 0 equals 0. When does 0 equal 0? All the time. So this isn't all reals, this is infinitely many solutions. No.
Wait, would it only be for zeta?
No, for everything. It's infinitely many solutions because now we can't have you can't have just one answer for y and z. You can't leave it like this. Okay? I'll talk about why it's infinitely many and not all reals in a second, but you can't leave it like this. All right? So we're going to have to go further with this. Yes? if you get any row of all zeros, then it's infinitely many. Yeah, no matter where the row. All right. So what we have here is this. What information do we have from row 2? Well, that y minus 3z, I'm sorry, y plus 3z is equal to 3. Okay? Now, because here it was row 3, which would have given us information on z, because it was that which got eliminated, then you want to solve this for z. Okay? I'm sorry, solve it for y. Yeah. So solve for y, and we get y equals 3 minus 3z. Okay? Now, what information did we get from row 1? X plus 2y plus z is equal to 8. You solve this for x. Okay? So we get x is equal to minus 2y minus z plus 8. Yes? But now, do we know what y is? Y is 3 minus 3z. So let's plug that in here. Okay, so let's distribute and solve, or simplify rather. X is equal to minus 6 plus 6z minus z plus 8. X is equal to 2 plus 5z. Yes? Now what's our answer going to be? Remember, your answer has to have the form x, y, z. What's x? 2 plus 5z. What's y? 3 minus 3z. And you have a z. Okay? No. Yes. No. And you won't have to do it that many times. So, what does it mean that it's infinitely many solutions? Now we have 3 planes, right? So there is a possibility where your 3 planes are all parallel to each other, which means how many solutions are there? How many places do they meet? This is no solution, right? There could be a possibility, so this is no solution. There could be a possibility that here is one plane, here is another plane, and here's your third plane. So you have 2 planes, parallel to each other, and another one vertical and crosses between those. So what's the point where all 3 planes cross? None. So this is also no solution. However, you can get a situation, and I'm not an expert at drawing this, but you can get situations where all three of your planes cross like this, like the pages of a book, right? So you have 1 plane, 2, and 3. And all 3 cross at this line here. That line, how many points does that line have on it? Infinitely many. Okay? So it's infinitely many solutions. Is it all real numbers? All real numbers would have been if they would cross like everywhere in space. But it's not like that. It's only on that one line that they cross. So it's infinitely many, but not all reals. Okay? All right. Let's do this one. See what we're going to get here. So we have 2, 3 minus 1, 1, 1, 1 minus 2, 5. All right. So we're going to get rid of this one. And I'm going to do row 3 minus row 2, so I get a positive here. So row 3 minus row 2. It doesn't matter. You can do it any which way. 0, 1, 3, 3. 1, 1, negative 2, 5. Those remained unchanged. What else? Now I need a 0 here. So I'm going to do 2 row 2 minus row 1. So the first row will be unchanged. And so will the third row. I'm doing 2 row 2, sorry. What are we doing? What did we say? 2 row 2 minus row 1.
Wait till you get rid of
This one here, that's circled. So 2 minus 2 is 0. 2 minus 3 is minus 1.
Can you do R1 minus 2, R2?
Yeah.
Keep it all positive?
Either way. So here we have negative 4 plus 1, negative 3. And what do we have here? 10 minus 1 is 9, right? Now I want to get rid of this one here. So I'm just going to add. Okay, so the first 2 rows will be the same. And for row 3, what do I do? Row 3 plus row 2. 0, 0, 0, 12. Well, what do I have here? That 0 equals 12. When does 0 equal 12? Never. This is no solution, and for this, you can just stop. Okay? All right. So the homework is due tomorrow.